Alright, welcome back everyone. In this video, we're going to build on what we talked about last time with object-oriented programming, and I'm going to explain inheritance to you. We'll just really scratch the surface of what you can do with inheritance. It's one of the really powerful aspects of object-oriented programming, what makes it so useful. And hopefully I can explain how this might be useful for your airfoil project. So, looking at the code that we started out with last time, we defined a cylinder class, we defined an airfoil class, and for each one of these we had initialization functions, we had geometry functions, and we had streamline functions. And then we defined some class outside of that that said plot streamlines. Now, there's a lot that's in common between a cylinder and an airfoil here. For both we've got some operating conditions. So we've got an angle of attack, and we've got a free stream velocity. This streamline function that we've written should also be basically the same between the two. All streamline is doing is it's taking a start location and a step size, and it's plotting your streamlines. So there's a lot of common functionality between these two classes. So what we're going to do is define a parent class for these. And I'm going to call this parent class potential flow object. So this is just saying this is a class that defines an object that is in potential flow. And for my initialization, I need to know it's, again, I put self. I'm going to do the angle of attack and my velocity, and then I'm going to store those. Now, then what I do to make these cylinder and airfoil classes children of this parent potential flow object class is I just put a parentheses after the name, and I say potential flow object. And what this means is that cylinder and airfoil now inherit from potential flow object. They are subclasses or children of this potential flow object class. And we refer to potential flow object as the parent or the super. Super is important because we can use super to reference functions and variables from this original class. So notice that potential flow, in order to initialize that, we need an angle of attack and a velocity. Well, we don't have that anywhere in our cylinder or airfoil initializations. We've just given it certain geometric parameters. So let's say now for our cylinder, we need to specify not only r and x center, but we also need to give it alpha and the infinity. Now we could, if we wanted, just store self.alpha is equal to alpha, and so on and so forth. But that's a little repetitive. We're not taking advantage of this polymorphism of the inheritance. So what we do instead is we just call super, and that's referencing, again, the super for this class, so it's referencing the potential flow object. And I'm going to call its initialization function, and I'm going to pass in alpha and the infinity. And that's it. So what I've done is in the initialization function for cylinder, I've stored the things that I need for cylinder specifically, and then the stuff that I need for a potential flow object in general, I've supplied using the initialization for potential flow object itself. So now I'm going to do the same thing down here with our airfoil, and for an airfoil, we don't give it r, we'll just leave those for now. We're also going to do alpha and v infinity. And we can copy this same line over and reuse it here. Okay? Now the really cool thing now, so we've done this initialization, we've shown how they can share member variables, they can also share member functions. So the streamline function, like I said, all you do is you give it a point, and then you give it a point and a step size, and it calculates your streamlines for you based off of the velocity. Well, that should be the same between cylinder and airfoil. So I'm going to make streamline a part of my potential flow object class, and I'm just going to get rid of it out, or get rid of it from airfoil and cylinder. But since airfoil and cylinder both inherit from potential flow object, they both now have this streamline function. So I can call streamline from potential flow object, from cylinder, or from airfoil, and it'll do all the same things. Now, if in here I've got, you know, a while loop that I'm running through my streamlines, and each step I'm calculating the velocity. Right. At some point where I've initialized point is equal to start. You know, I'm being very general here, but this is kind of what yours is going to look like. And then break, so it doesn't get mad at me. This velocity function, notice potential flow object doesn't have a velocity function. But that's okay if we have down here defined velocity, self, and point, and then for now I'm just going to return 0, 0. Now, since this streamline function, it belongs to potential flow object, but it also belongs to cylinder airfoil. So if down here I call my cylinder dot streamline, and I give it a starting location and some ds, then it'll go in here to the streamline function and it will use the velocity function that's defined for the cylinder. Same thing if I had done it with an airfoil. So this is where things get really powerful. You can define this parent class that wraps up all of this common functionality between these subclasses. So you don't have to copy your code over and over and over again. And then for your specific subclasses, you just define what is needed specifically for that. So, you know, for a cylinder, we've got a specific geometry and a specific velocity. We'll probably also have functions for specifically determining stagnation points. For example, on an airfoil, you know that the aft stagnation point is always the trailing edge. So there's special functionality like that, but all of this general functionality we can wrap up as part of this potential flow object class. And I can even take this plot streamlines function, and I can make that a part of my potential flow object. And then instead of giving it a flow object, I'm just going to call it as a member function of my potential flow object. And then it'll do all that plotting for me using the streamline function that I have defined up here. Okay? It's honestly, object-oriented programming inheritance is really cool. It's really useful. Like I said, we've really only scratched the surface here, but I hope this has made clear for you how you can, again, wrap up common functionality in parent classes and then specialize with child classes. And then remember, the child class inherits everything from the parent class. And so you have access to all these functions that are defined up here. Now, if for whatever reason you had some potential flow object where you said, okay, the streamlines for this are a little different. So in my cylinder, if I wanted a special streamline function for cylinder, then I could just do def streamline here. Whoa, that's cool. I could do def streamline here, and it will do some other calculation. You know, whatever I want my special streamline function to be. So now for airfoil, it'll still use the streamline function that's defined in the parent class, but down here we've overridden that member function from the parent class. So it's no longer going to reference the parent function, it's going to reference what's defined here in cylinder. Okay? I think that's all I want to talk about for this. I hope this is helpful. Based on your feedback, I might produce another video where I explain a few more aspects of this, but this should get you going for the most part.